trigonal, planar, trigonal, pyramidal. Going to be an electrostatic attraction between the oppositely charged ions. Alright, so that's number 3 types of intermolecular. Regard as a permanent dipole. So that partial negative is going to be attracted to the partial positive. The type of intermolecular force at work here is permanent dipoles. In this arrangement, the carbon dioxide molecule is what we regard as non-polar. And since it's non-polar, the nature of the intermolecular is going to be van der Waals forces, right? So we know that this is hydrogen bonding. Stronger hydrogen bonding makes for larger melting and boiling points. Assume stable positions where they are equidistant apart. The name of this structure is called face-centered cubic surface particles. So temporary dipoles is very weak van der Waals dispersion forces, right? And it's going to have optical properties. This structure is dominated by bonds. There's one, size of cations decreases. Push on these bonds, right? And based on the valence shell electron repulsion theory, this weak force of attraction is van der Waals, V-shaped. This is called sp3 hybridization. One single bond into carbon, you can see it here. And then we have the hydrogens as well. So hydrogen, and here we have hydrogen, hydrogen, hydrogen. So sp2 bonding. So this is the sp3 hybrid orbitals, right? Both ends, end to end, is tetrahedral. The plotting wave function like this. So this is the 2s, the function for the 2s, plus the function for the 2px, right? Explains that shape that we see, right? Right. So this is called a pi bond. A triple bond will consist of one sigma bond and two pi bonds, which is this overlap above and below the internuclear axis. And that's how we get the alternating double bonds. And you can see the sp2 hybridization produces this shape, right? So we get a lobe above and a lobe below. That really looks like this. One lobe, and here we see it's a delocalized ring of electrons. And a better term is resonance. We could see that the shape of the benzene is planar. But in this case, C3H6O3 would be molecular formula. And this one down here would be empirical. So the empirical formula would be this, CHO, right? For every one carbon, there's two hydrogens and one oxygen. We have a fuel reacting with oxygen. Out of the 1.91 grams of CO2 that was collected, 0.52 grams is carbon. So in this case, the empirical formula and the molecular formula is the same because both of these is equal to 1 dm. So it's 2 here and 2 there and equal balance, right? In excess oxygen, and it's going to produce 0.448 dm cube of CO2 gas.